All right, this video is going to start by grading the homework for molar mass, which was technically 10-2. It's out of 62 points, so make sure you have a score at the top. Silver, AG. You go ahead and figure out that it's 107.9 grams per mole of AG. Work is 1 point, half point for the answer, half point for sig figs. You remember you always have to have one decimal place. Units are grams per mole. AG is a substance. For oxygen gas, that's O2 because it's a diatomic. 1 point for work, 32.0 grams per mole of O2. You definitely need to have that 0. If you don't have that 0, it's minus a half. Number 3, we have the answer, 149.0. We did that one in class. Make sure you have one decimal place. Glucose, 72.0, 12.0, 96.0 gives you 180.0 grams per mole of C6H12O6. Remember, you need that 0 in the one decimal place. 5, sodium chloride, 23.0 plus 35.5 is 58.5 grams per mole of NaCl. Calcium sulfate, CaSO4, 40.1 plus 32.1 plus 64.0 gives us 136.2 grams per mole of CaSO4. Calcium carbonate, you have 1 point here for CaCO3, and it's going to be 40.1 plus 12.0 plus 48.0, which gives us 100.1 grams per mole of CaCO3. For number 8, you have aluminum nitrate. For the name, that's worth 1 point. And then for the work here, 27.0 plus 42.0 plus 144.0 gives us 213.0 grams per mole of AlNO33. Barium hydroxide, remember 2 capital letters, you got to put a 2 here for the reduced crisscrossing. If you don't have a set of parentheses here, you're not going to distribute this 2 to the oxygen, which means this answer is going to be wrong, which means this answer will be wrong. So this is worth 1 point, all or nothing. If you forgot the parentheses, it's minus 1. You would lose a half point here, and then a half point here for the answer, and a half point here for the substance. So it's 137.3 plus 32.0 plus 2.0 gives us 171.3 grams per mole of BaOH in parentheses 2. 10, the name is titanium, Roman numeral 4, iodide. If you forgot the Roman numeral, it's minus a half. You get 47.9 plus 507.6, which gives you 555.5 grams per mole of TiI4. Please make sure you write how many you missed at the bottom. Moving on to the next page, hopefully you realize that we looked at molar masses that you calculated on the previous page or have done them in the notes. So 11, you take moles, you want to change moles to grams. Remember, you need one decimal place in all molar masses. If you don't have that, it's minus a half. The answer is 11.0 grams of O2. Half point for answer, half point for sig fig, half point for unit, half point for substance. If your rounding was wrong, like I don't know, let's say you accidentally rounded this to 11.1, it'd be a half. 12, you take 16.3 grams divided by the molar mass of water, 18.0 grams. The 1 mole goes in the numerator. The answer is 0.906 moles of H2O, or 9.06 times 10 to the negative 1 moles of H2O. Remember, you don't need both answers, just one. 13, 14 moles times the molar mass of C6H12O6. Remember, you got to have that one decimal place. If you don't have it, it's minus a half, 2,500 grams of C6H12O6. For 14, you have 342 grams of NaCl divided by 58.5 grams of NaCl, which gives us 5.85 moles of NaCl. 15, you have 3.80 times Avogadro's number, 6.02 times 10 to the 23 formula units. If you wrote the wrong formula here, it's minus a half here. So in other words, if you didn't put parentheses and over here. Luckily, it didn't affect your answer, 2.29 times 10 to the 24th formula units. If you don't have the power 10, it's minus a half. Here, you have 1.52 times 10 to the 26 formula units. You got to multiply by 1 mole over Avogadro's number times the molar mass of CaCl3, which you found on the previous side of this worksheet, 100.1 grams, and you get either 25,300 grams of CaCl3, or you could put in scientific notation, 2.53 times 10 to the 4th grams of CaCl3. 17, I try to help you out by putting bromine in a bold font. Remember, it's a diatomic. We found this value on the notes. So you take the molecules of bromine, got to divide by Avogadro's number, multiply by 159.8 grams of Br2, What if you just left it as 79.9 because you didn't take into consideration the BR? Overall, the entire problem, you would lose minus 2.5, and that's how it will be on the practice quiz, and it will also be like that on the real test review, so make sure you account for that. And then the final answer would be 1,510 grams of BR2, or 1.51 times 10 to the third grams of BR2. Write how many you missed at the bottom, and then you should have a score out of 62. Once again, save that for the next time I see you. All right, the next page in your homework packet is 10.3. That's extra practice if you want to do it. I do have the key for that, but you don't have to do it. It's extra practice if you would like to. The following page in your homework packet is going to be the practice quiz. That is one of the things that you have to do along with percent composition. So now what we're going to do is learn about percent composition. Percent composition is the percent by mass of each element in a compound. So here I have the mass of the element over the mass of the compound times 100. Mass of the compound is the molar mass, and then remember when we multiply by 100, it's just to get the percent, so it has unlimited sig figs. So if I had a sample of water, what is, right, the percent composition of each element? So here I have H2O. In the work here, I'm going to have the mass of H over mass of H2O times 100. Well, you have to take into consideration that it's not just one H, there's two H's overall. So I have to put 2.0 grams over 18.0 grams times 100. And this is the exact work that I expect for your homework. We will do one practice problem in the homework, but I do need to see, right, the numerator, denominator with units multiplied by 100. When I multiply that and divide by 18.0, I get 11%. Why is it just 2 sig figs? Because there's 2 here, 3 here, unlimited. For the O, same thing. I'm going to take the mass of oxygen. There's only one O. 16.0 divided by 18.0 times 100. That gives me 88.9% O. Put the unit, put the substance. Why does it have 3 sig figs? 3 sig figs here, 3 here, unlimited. Now, application of percent composition. How many grams of hydrogen is in a glass of water containing 648 grams of water? Well, if I have 648 grams of water, I'm going to take into consideration, right, that it's 11% hydrogen. So I'd have to know the percent composition first. So remember, water is 11% hydrogen. So I'm going to take 11% of 648, which means I'm going to take 648 grams times a percent, change into a decimal, and I get 71.28 grams. But remember, 3 sig figs, 2 sig figs, I can only have 2. 71 grams of H would be my final answer. Last thing we're going to look at today is empirical formula. Empirical formula is really looking at the meaning of what a formula tells us. Does it mean 2 moles of hydrogen for every 1 of oxygen? Always. So formulas are not only ratios of atoms, they're also ratios of moles. So formulas are ratios of moles. So here, empirical formula is the simplest whole number ratio of moles of the atoms in a substance. Experimental method, that is the first step in finding the formula of a compound. But I first have to be able to recognize what an empirical formula looks like. So we're going to practice that. We're going to classify if it's empirical or a molecular. Remember, molecular can be anything. Empirical would be simplest whole number ratio. So if I look at H2O, 2 and 1, are those in lowest terms? Yes, empirical formula. NaCl, 1 Na, 1 Cl, yes. C2H6. C2H6 can be divided by 2. So that would be a molecular formula. I would divide by 2. So the empirical formula would be CH3. 1 is understood after the carbon, but you can write it if you want. NO2, 1 to 2, empirical formula. H2SO4, a lot of students always want to say, well, the SO4 is together. But no, you have to look at it as 2 H's, 1 S, 4 oxygens. So that's an empirical formula. The next one, C6H12O6. So this is a molecular formula, dividing by 6, empirical formula, CH2O. For N2O4, that's a molecular formula because I can divide by 2. So the empirical formula is NO2. Now what we're going to do is look at the homework. All right, once again, 10-3. 10-3 is optional. You do not have to do this. I would do this if you feel like you need more practice with day 1 and day 2, but you do not need to do this. All right. Part of your work for tomorrow, though, is to definitely do this practice quiz. So make sure you do this. I would try to do this after I've looked over the homework, looked over the notes, then put everything away and just have your periodic table out. On the real test, right, you can't use the stoichiometry island diagram, so make sure you know how to go from each step and see how you do on this. We'll check this in class next time I see you, so you have to have it done. So then the other homework, which must be uploaded, is this here, 10-4. 10-4 at the bottom, okay, and it is two-sided. So I want to do the first one with you because I want you to know what to expect for work. So we actually have already found the molar mass of NH4,3PO4 on yesterday's homework. So I have the information here, right? So N, right, for NH3PO4, N, there's 3 of them, times 14.0, that gives me 42.0. H, I had 12 of them, times 1.0, that gives me 12.0. Phosphorus, 131.0. And then oxygen, there's 4 of them, times 16, gives us 64.0. So then our total was 149.0. Okay? So now for percent nitrogen. The percent of nitrogen in this compound would be the total of nitrogen. So not just, right, not just 14. It's the total nitrogen in the compound. So 42.0 grams divided by 149.0 grams times 100. Don't forget the 100. That's important. That's worth a half. So when I put this in my calculator, right, I get an answer. And I'm going to take 3 sig figs here, 4 sig figs here. So I get around to 3. So my answer is 28.2% nitrogen. So this is what I expect for work. Okay? This next one, percent hydrogen, would be 12.0 grams divided by the same denominator times 100. I got to round that to 3 sig figs. That's going to be 8.05% hydrogen. Phosphorus, the total phosphorus is 31.0 because there's only one. Divide by the molar mass of the entire compound. Round to 3 sig figs. That's going to give me 20.8% phosphorus. And then the last one, total percent of, or total part of oxygen is 64.0, not 16. So 64.0 grams divided by 149.0 grams. That gives us 43.0% rounded to 3 sig figs. This one, 10-4, front and back, has to be done. And then the practice quiz should be ready to grade in class next time I see you. If you have any questions, make sure you email me.